Atomic structure conversions are the most important types of conversions in chemistry. They're divided into two broad categories, counting and mass-related conversions. The counting conversions tend to answer the question, how many? For instance, how many carbon atoms are in a sample? The mass questions tend to address the how much question. We might want to know how massive a sample is in grams or kilograms. The counting variety always involves Avogadro's number, which I'm abbreviating M sub A. Avogadro says that 1 mole is 6.02 times 10 to the 23rd of something. Just a counting number, just a group. Because that's an equality, we can put it into a conversion factor, 1 mole of something, 6.02 times 10 to the 23rd of that something, or 6.02 times 10 to the 23rd of that something over 1 mole. The important note here is that the thing that we're counting can vary. It doesn't have to be atoms, could be molecules, could be school buses if we wanted it to be. On the mass side of things, we have a new equality that's of use to us. 1 AMU is equal to 1 gram per mole. What that means is that the values on the periodic table just became a whole lot more important. We're going to use a convention in the course that relates to rounding. All students should be rounding molar mass values to 1 decimal place. We know that for calcium, the molar mass would be 40.078. We're going to round that to 40.1 so that we're all on the same page. To create a conversion for a by mass type of problem, if we know that some amount of grams is equal to 1 mole, we can make our fractions so many grams in 1 mole, or 1 mole so many grams. Note how our approach has changed on the right side. Now, instead of having a unit that could differ, we have a number that changes based on the value that you're looking up on the periodic table. 2 quick examples, one for each type. If we were asked to convert 3.6 times 10 to the 24 atoms of carbon to moles, first and foremost, I'm recognizing 3.6 times 10 to the 24 as 36 times 10 to the 23. 36 times 10 to the 23 is roughly 6 times Avogadro's number. So in my mind, I'm thinking that my final answer is going to be around 6 moles. It does help to set it up, and you'll be expected to set it up either way. 3.6 times 10 to the 24 atoms of carbon. I want to get rid of atoms of carbon. I'm going to moles of carbon. 1 mole of anything is equal to 6.02 times 10 to the 23rd. I'm noting that my units are canceling. My final answer ends up being 5.98, which, because of significant digits, 3.6 has only 2 significant digits. I'm rounding to 6.0 moles of carbon. My answer ends up being 6, the way I predicted in the beginning. On the other side, for mass, convert 120 grams of calcium to moles. In this case, I'm wondering, what is the molar mass of calcium? And once again, looking it up on the table, rounding it to 1 decimal place, we have 40.1 grams per mole. If 1 mole is 40.1 grams, how many moles would we have at 120? Well, in my mind, I'm thinking that it's around 3. Of course, I'd want to do the math just to check, particularly when rounding is concerned. The gram has to go below. My mind has been made up for me with that one. I'm trying to change to moles. Wouldn't it be terrific if we knew a conversion factor that told us how many grams in 1 mole? We do. It's the periodic table, 40.1. We end up with a value of 2.99, which is ending up at 3.0 when rounded appropriately.